Hi, everyone.
All right, everyone, so we're going to get started. I'm Michael Burris. I'm the town planner here in Westport. We're here tonight to talk about a couple of culvert crossings on Drift Road and Cornell Road. I think about 8 months ago, Buzzards Bay Coalition had reached out to me, and we knew that the town has known that these culverts have been failing for some time. Buzzards Bay Coalition had reached out and said, hey, there are a couple of grants out there that we can look into and apply for and start to develop some designs and see what's possible for replacing these culverts. So this is the first public meeting we're having for this process, and they're going to, Gomez and Sullivan and Buzzards Bay Coalition are going to present the results of their preliminary designs, as well as the results of the analysis of the culvert crossings.
Great. I'm gonna, it looks like the screen hasn't connected here. What should I do?
Oh, if you hit the input, the bottom button right here.
Oh.
I guess we operated here. Do you stand out there?
I think if you
just stand back here. Okay.
Yeah, back here. Hi, everyone. My name's Evelyn. I am the restoration coordinator at Buzzards Bay Coalition. So if you've had any questions about the project or reached out, I'm who's on the other end of the phone. Thank you for coming tonight. I want to give a little bit of an intro of how this project came to be and what got us to this point. So,
Sure. Okay.
So this project is part of the Buzzards Bay Watershed Restoration Partnership. It's a bit of a mouthful, so you'll hear me refer to it as the partnership. Our goal is to see Bay watershed communities that value, support, and actively advance restoration of important natural resources in the region. So the partnership began in June of 2022. It is led by the coalition and supported by DER, which is the Massachusetts Division of Ecological Restoration. But the real meat of this partnership is all of the stakeholders that are involved. So we have municipalities, land trusts, state agencies, county agencies, federal agencies, tribes, and other organizations. And in each project, it's a different set of partners, but many of them overlap, and they all help to raise up those projects, and we look for ways that we can work hand in hand. So when this partnership was started, we're looking through the Buzzards Bay regional area, so anywhere in the watershed where water is eventually ending up into the bay. So this is all the towns shown on the map, and we looked specifically for kind of two things that entered into what we call a prioritization model to show us what kind of projects led to the top. So the first thing is we're looking at the restoration potential of these projects. So for example, in Westport, in these cold water streams, we have really great opportunities for fish passage, specifically American brook trout. And that kind of brought us to an ecological restoration standpoint. But the second thing that really is part of the prioritization model is looking for partners such as the town of Westport who are looking for projects that are a priority on their end as well. So with these three culverts, they are in a different stages of deterioration, and so it's one of the priorities for the town as well. And so those two things brought these three culverts to some of the top culvert replacements in the region. And so, you can advance it. So just to kind of walk us through the timeline here, in 2022, we completed that prioritization model with Angeline, Snell, and Lyons emerging to the top. In 2024, the coalition obtained funding through DER, the Division of Ecological Restoration, as well as the Buzzards Bay National Estuary Program. And that was able to, that money brought us able to complete data, so initial data collection and looking at conceptual design. So this is about 30% engineering. And so that's Jill for us. This is Jill Griffith. She's going to be presenting tonight on that information. And on our end, we will be looking for the next series of funding for this project, but that's getting ahead of ourselves. I'm going to pass it off to Jill.
Sure. Hi, everyone. Thank you, Evelyn, Michael. I'm Jill Griffith. I'm a water resources engineer with Gomez & Sullivan Engineers, and I've worked on a number of these culvert replacement projects throughout Massachusetts that are designed in accordance with the state's stream crossing standards to be larger structures to accommodate both ecological and fish passage goals, as well as improve storm resilience. I'm just going to go back to the title slide to just show you the 3 sites that we studied as part of this project. So on the left we have, is it okay if I stand here? Can everyone hear me? Okay. On the left we have the Angeline Brook crossing at Cornell Road, and then 2 crossings on Drift Road, Snell Creek going under Drift Road, and then a little farther north, Lyons Brook. So those are the 3 crossing sites that we'll be talking about. And just skipping back over there, so just to give a little overview of what I'm going to talk about, Evelyn already covered it pretty much, but the project partners and funding sources for this phase, the purpose and goals of the project, a little bit about the watershed, what exactly we collected for data, and what our analyses involved, and then show you the conceptual designs that we came up with and talk about next steps. So as Evelyn mentioned, there's the partnership, and specifically in this phase, the town of Westport, Buzzards Bay Coalition, the Estuary Program, and DER were involved in either the partnership or funding. So as I mentioned, the purpose of this project is to replace these 3 culverts. They are deteriorating. They're in very poor condition. They are undersized, which means they don't fit the appropriate storm flows through them that culverts are supposed to be designed to pass. And so that's kind of the problem, and the purpose is to replace them with larger structures that are designed in accordance with the state's standards for stream crossings. And here you can see this is just kind of a collage of a number of different problem areas at these 3 culverts. As far as fish passage and ecological considerations, a number of the outlets are perched, which means that the opening is above the bottom of the stream channel, and often there's no water there, so the fish and other organisms can't get through the culvert. Many of them are very small, undersized, as I mentioned. This is Lyons Brook. You can see it's very shallow depth to the top of the road, so it frequently overtops, as many of you know, I'm sure. This is Snell Creek, and this one is in very poor condition. You can see the head wall there is comprised of a hodgepodge of different granite blocks and concrete blocks, which are being undermined from behind. This is a sinkhole on the landward side behind that wall. And many of them are submerged or blocked, so they're not getting the full capacity that was originally intended. So those are kind of some of the problems. And as part of this project with the replacement structures, some of the goals and benefits that we anticipate are, first and foremost, a benefit to public safety. These culverts can fail, and it can often be catastrophic. This picture is actually from my hometown just last week. I just had to throw it in there because this is a state road, and we got 4.5 inches of rain in an hour and just washed the culvert right out. So that can happen even on bigger maintained roads and with these smaller undersized pipe culverts. And it can happen unexpectedly and cause outages and of utilities. There's gas lines in these roads, and also closures of the road and so forth, while a new culvert then has to be designed and installed, which can be a longer outage than if it was properly planned. By replacing them with larger structures, as I mentioned, there will be increased resilience to larger storms and less overtopping of the road. By not having to deal with these washouts or even more minor washouts, it's less maintenance and cost for the town and to the taxpayers. Improved water quality, I can show a little more on the next slide, but these small undersized culverts can actually cause water to back up on the upstream side of them, which can make that water stagnant and warm. As Evelyn mentioned, these are designated cold water streams, which is a special designation from the state. That means they're protected and they have nice, clear, cold water that supports various species, such as the sea run brook trout that Evelyn mentioned, Also, other species that could be present include American eel and sea lamprey. As far as species that migrate and need to move back and forth between freshwater and saltwater environments to complete their life cycle, as well as other aquatic species that just live in the freshwater streams as well. So it will improve that water quality by opening that up, reducing that stagnation, reducing the amount of siltation and things that are eroding around the culvert, and also we'll be addressing some stormwater as part of the project. And lastly, due to that and just the overall connectivity, it will enhance habitat and passage for fish and other species. So this is just a graphic showing a little bit of what I was talking about with some of the problems with undersized culverts. So this is the culvert barrel or pipe, and flows coming down through the culvert this way. As you can see, here's what I was talking about, where it's a perched outlet where fish can't get up into it. Because it's undersized, there's a lot of force coming from that water that can't fit into the pipe, so it causes scour holes on the upstream and downstream sides, which eventually can undermine the culvert, and that's how in that previous photo you saw, the culvert just washed right out from under the road and kind of went downstream. And as I mentioned, the upstream flooding, because it starts to back up because it can't fit through, and then it can go over the top of the road. So shifting now to zoom out to the watershed, just to give a little context, this is the Buzzards Bay watershed on the left, and zooming into the Angeline Brook watershed here, and the culvert is down here, goes into the Westport River, and then the Snell and Lyons Brook crossings over here are smaller watersheds, and they go into the East Branch. Excuse me. Just think if there's anything else I want to say about that. I don't think so. So first, in order to understand how to design these culverts, we went out in the field and collected some data. So we went out last summer and collected a bunch of different types of data on the streams. We did wetland delineations. We went out with survey equipment and measured the elevations of the channel and the surrounding land. We surveyed cross sections across the river channel to see what the channel shape was like. We collected sediment, which is kind of the substrate in the river bottom, stream bottom, whether that's sand or gravel or cobbles. We looked to see what it was like right at the culvert and then further out where it was a more naturally functioning stream, so that we could then replicate that material in the redesigned new crossing. And finally, we measured bankful width. Excuse me, I guess I have another one, but bankful width, which I'll talk about more on the next slide, is kind of the appropriate width that the channel is supposed to be and that the crossing should be designed to accommodate. And we also did a geotechnical investigation. Some of you might have seen the drill rigs out there earlier this year in February, I believe. So basically drilling into the road shoulder to determine the depth to bedrock, which is important to understand how to structurally design the culverts and footings. Oh, and I didn't mention hydrologic and hydraulic modeling, so that was a very important one, where we look at the flows coming into the system in the brooks. Excuse me. And then we have a model that we can run, a hydraulic model, which takes those flows and the topography information, the kind of elevations and cross-section shapes that we measured, and it puts it all together and tells you what the water surface and velocities and various parameters will be throughout the brook. This just shows a little bit more what I was talking about with bankful width. So you can see here in this photo, a typical stream, you might think of the width of the stream as kind of the wetted area that you see the water under normal flows. But when the flows get higher, when the stream is flowing full up to the tops of its banks, but not overflowing onto the adjacent floodplains, that's called the bankful flow. And it's an important flow for people who study rivers and design channels and crossings, because it's what's referred to as the channel forming flow. At that flow, the stream has the right combination of forces to kind of move and settle out different sediment throughout the system. And so that kind of defines the shape of the stream. And so the stream crossing standards from the state use that parameter as a requirement. So any new or replacement culverts designed in this state, unless it's an emergency situation, typically have to be designed to accommodate the bankful width and then an extra buffer. Excuse me, sorry. And an extra buffer of 1.2 times the bankful width. So these are the measured, as I mentioned on the previous slide, we took at least 6 measurements of bankful width throughout the stream, averaged them, came up with a recommendation of a representative bankful width, and then multiplied that times 1.2 to get our proposed stream crossing widths. So that is what the new culvert widths will be. And that's, you'll see later, but the existing culvert pipes are typically, 2, 3, some are 5 feet wide. So definitely a drastic width increase there to allow more storm flows. So I've been mentioning the stream crossing standards, so just to dive into that a little more. As I mentioned, it is required for any newer replacement crossings. There's the reference to the code, and you have to show that you're meeting it to the maximum extent practical, and you have to look at various different metrics, including engineering costs, different constraints of the site, etc. So what the standards there's a number of criteria that you have to try to meet, and first and foremost is the type of crossing. So again, a lot of these existing structures are pipe culverts, just kind of stuck in the road, and no natural stream material or anything like that within the culvert. Some of them do have, they transition partway through the culvert. Some have like a pipe on the upstream end, then an open bottom kind of old stone culvert on the downstream end. So some of the preferred crossing types under the stream crossing standard are anything with an open bottom, so a natural stream bottom, as you can see in these photos. This one is a common design. It's called an open bottom box culvert, or it's a concrete structure that has 3 sides and no bottom, so it's natural stream bed through the structure. Down here, it's a similar type of situation, but it's a corrugated metal arch. It can be a little more cost effective sometimes. This one has more longevity. So you kind of weigh both options. Other types, you can do an actual full pipe, but you have to bury it to the point that you're getting at least a certain amount of stream material in the bottom. So imagine if this was a really big pipe, it's buried so that like about a third of it is full. That is acceptable as well, but it can be hard to achieve that. You'd have to dig really deep and can't be accommodated at all sites. So these are the typical 2 types of crossings that we're looking at, and this really is the preferred one for most projects. You also have to look at how open the structure is, a certain ratio of cross-sectional area versus its length, the bankful width, as I talked about. You need to look at water depths and velocities and make sure they're comparable to other areas of the stream that are more naturally functioning, and the substrate that I talked about before. So whatever combination of cobbles or gravels or whatever you're seeing elsewhere in the stream where it's functioning naturally is what you want to design to place through here and have it be stable. So you don't want it to all just wash away under the first storm. So you have to design all that so that it's going to remain stable and get established like you can see here. So I think that's about it for the standards. So now we'll get into the conceptual designs for each site. And these are a little hard to look at. They're engineering plans, but the point of this is I just wanted to show you an overview to show you kind of the work area involved with each structure. So this is Angeline, and this is the upstream end coming through the road and down, sorry. Oh, yeah. I was thinking it looked like it was impounded here. That's because of the cofferdam. Yeah, so coming downstream like this, and this is the road crossing across here. And for the project, it would need to be dewatered to place the culvert. So a pipe would be placed through, and you'd have cofferdams, which are kind of like those big white sandbags that you might have seen at different culvert replacement sites to dewater this area. And this would kind of be just the general work area around that structure. So zooming in to see the proposed design, as I mentioned, the existing has these 2 stone and pipe culverts that are about 5 feet wide each, so about 10 feet total, going to a 29-foot wide open bottom. It will be considered a bridge under Mass DOT standards. Anything greater than 10 feet is considered a bridge and regulated by their program. So that is what's required here in order to pass the larger flood flows. And you can see kind of a cross-sectional view of it here. So again, existing with the 2 pipes, going to the open bottom. And this is kind of the channel bed. Excuse me. It's a little hard to see, but we always like to design what's called a low flow channel in the center, because if it's flat all the way across, during periods of low flow, you'll end up with very shallow depths that won't accommodate fish or other aquatic organisms. Sorry. Okay, so that was Angeline. Then moving on to Snell.
Just one
Yep.
quick question.
Yep,
Could you go back to the?
sure.
So, I see Cornell Road, and the bridge is built a little wider than the road. Is that, am I seeing that correctly?
Yes.
So allowing,
The head wall is called the head wall here, so that extends beyond, and it allows enough space for a road shoulder and a guardrail, which will be required since this is a bridge, this larger structure here. So that's why it extends a little beyond.
What are those things going down?
These are the wing walls. So let me go back to the photo. You can kind of see here the angled
Oh,
walls that hold back the embankment. More questions? Okay, so this one is Snell Creek. And similarly, so we have the stream coming in from here. It actually has a tributary which joins it right at the upstream end. And then they flow under the road here and come out. So this is kind of the work area. And then I'll zoom in. You can see the existing 2 pipe culverts there. Or sorry, excuse me, there are pipes on the upstream end, and they transition to stone box culverts on the downstream end. And then that will go to a replacement 10-foot wide open bottom box culvert. And similarly, you can see the channel shape here with the low flow channel. And then lastly, at Lions Brook, this one comes in from over here, flows under the road, and then goes out. And this is the replacement. This one shows 2 pipes, but actually this pipe is fully blocked. So flow is only flowing through that pipe. You can see that there. And then this would also be a 10-foot wide. If you were keeping notes on my earlier slide, I said it only had to be 7.6 feet wide. Excuse me. But because this one is so shallow, as I showed in that first photo, it's really close to the top of the road. You can't get a lot of height or a lot of flow capacity with the minimum culvert size that would be required, and it would still be overtopping the road under certain flows. So in order to get flood flows through the culvert, which is what we want, not over the top of the road, we made it a little wider. We made it 10 feet wide, which is the maximum width without it being considered a DOT bridge. And we also made it a metal arch instead of the box culvert that we typically would use. Again, going with this metal arch because it's thinner. The concrete culvert requires about a foot thick for the top. So again, that's taking up available space that could be used for flood flow. So this is thinner, and so we did that to maximize the opening area for that type of structure. So that's what was proposed there. Any questions before I move on to cost? Yep.
Hi, do you recall how much bigger the Snell Creek capacity is going to be over the present?
Yeah, so I can talk about that. So each one is drastically improving the capacity. So I'll just start at Angeline. Angeline can currently pass only the 10-year flood. If you're familiar with, people talk about the 100-year flood. It's a probability of occurring 1% chance per year. And the 10-year flood is a much smaller flood. And that is all that can be passed by the current culverts. And we've designed all of these to pass the 100-year flood. Angeline was the toughest one without going much wider. We also like to check, so we like to design them to pass the 100-year with some freeboard, so some space, they're not flowing completely full. And then we check the 500-year to make sure it's not overtopping the road. And so that's what we've done here. The 500-year flow is under pressure flow, which means it is flowing full through the culvert, but it's not overtopping the road. The other two pass the 500-year as well, free flowing. So Snell is going from passing the 10-year for existing to passing the 500-year for proposed. And Lyons was even smaller. It only passes the bank full flow. So what I showed you earlier with the channel flowing full, that's all it can pass. Anything larger than that is overtopping.
On the Angeline Brook, there's a drainage ditch.
Yep.
that Comes down along the side of the road.
I was
on
gonna
the
talk
north-
about that. Thank you.
North side of the road.
Mm-hmm.
I don't see it in the plan. How are you gonna accommodate?
Yep,
that
I can talk about that. There's a tiny little
Oh,
corner
yeah.
of it there. So it does come along the road this whole way. And thank you for asking about that, because I meant to mention that. And that is a drainage ditch that collects stormwater and other flow. And it kind of gets stagnant and it heats up the water and then goes into the brook, so it's
It
causing
flows over the road.
that too, yep. And so it causes issues, and so the plan is to, along the way, before it gets to the brook, to design diversion level spreaders, they're called, to send the water into the woods more and spread it out so it can infiltrate and become cleaned and infiltrate into the groundwater before it re-enters the brook. So that's the plan for that.
Pretty extensive project.
Yep, it'll be incorporated as part of this project.
I have a question about the area that goes off the road. How far is it off the road? Is it a typical sort of, you know, if you can give me an example of existing width of road? And then what kind of, is there any kind of talk about what kind of guardrails do they have to be a certain type of guardrail, or is there options there?
Sure, yeah. So that'll be part of the next phase of design to figure out those details. There are several options for guardrails, different types. It's, especially for this one that's regulated by DOT, there are certain specifications that have to be followed. But for the other two especially, there are more options. So we'll be exploring that as part of the preliminary design. And the road shoulder, so the available space adjacent to the, is that what you're talking about? Yeah, that's also being considered as part of the preliminary design to ensure there's enough space for walking.
You know, it's heavily walkable
Yep.
road, and it's also heavily cycled road.
Yeah, definitely. That will be part of the consideration for design. So we're still looking at that. Okay. So for project costs, this slide just presents a conceptual estimate of total cost for the project. So the engineering analysis and design, we're partially into that phase, but there's additional work to be done for preliminary design and preliminary and final design and permitting. And then the construction itself and bid and engineering support during construction is included in these numbers here. So as you can see, these are not cheap projects, they are substantial, but this is the requirement by the state standards, and by designing it to the state standards, the projects are eligible for grant funding, which is what they have received and will continue to solicit for.
So can I ask a question about the funding?
Mhm.
So, in order to get that $4.4 million, we have to do what Mass DOT tells us for the two culverts that are going to be converted into bridges, right? We have to- we have to follow everything they say.
One will be a bridge, and regardless of whether, it has to follow DOT standards regardless, because it is that width. So, and all these projects have to be designed in accordance with the streams crossing standards unless they met a number of criteria which they don't meet. That would be the only way that they wouldn't have to be designed to those standards.
But
Is
the
that
town of
answering your question?
Westport can make a statement and tell Mass DOT or you or Buzzard Bay what they want in that bridge from a kind of a road passage perspective.
Yeah.
Like aesthetics and stuff.
Yep,
like that.
sure.
They can say, we want this versus something that's
Yes.
188 or 195.
Exactly, and the town is involved at this phase and will continue to be involved in selecting those alternatives, yep, absolutely.
I have a question about the funding as well. So how much grant money is coming in and how much town money has
no taxpayer dollars are going into these projects. So we've continued to receive some funding from Buzzards Bay National Estuary Program. It doesn't fully cover the next engineering analysis, and that's why we will continue to seek for grants. So one of those grants that we've applied for is the Federal Highway Administration. They have a grant for Culvert, called the Aquatic Organism Passage Grant. In tandem with that grant, if that is received, then we can receive the Massachusetts Federal Matching Funds grant, which will then kind of work those together. We know that funding grants are sometimes a little up in the air, and so we always apply for multiple grants. So Massachusetts has the Culvert Replacement Municipal Assistance Program. There's the Massachusetts Vulnerability Preparedness Program. So that's what Buzzards Bay Coalition continues to do, just continue applying for grants to get these projects done bit by bit.
That's great that
And
you're doing that, and there's no taxpayer dollars, because that would be problematic. I would imagine they'd have to go through the whole approval. And the other question I had is a timeline. What do you see as a timeline for this?
Sure, yeah, I think that's a good segue to my next slide. So the next steps for the project. So the town has indicated that the next step will be a presentation to the select board. And then, as Evelyn discussed, additional funding procurement. We do have some funding in hand at this point to get started with preliminary design. And then so preliminary design will involve more of those details that you've been asking about, the guardrails and the road shoulders and the different materials and structures. And then once that is at about a 75 complete design stage, the project will enter permitting. Permitting in Massachusetts is very extensive. They've tried to streamline it for these projects, these types of projects, which can be, most of these culvert replacements can be designated as what's called an ecological restoration project, which affords it some liberties during permitting or some more streamlined steps. But it's still a very extensive process, and it can take up to a year or longer. And so that'll be permitting, and then in coordination or in tangent with that, as we're getting comments from permitting agencies, we'll be incorporating those into the final design plans. And then finally, when the project is complete and the permits are in hand, the project can go out to construction bid. Construction will be completed. And then also, because it would be permitted as an ecological restoration project, it's assumed it would be required to do post-construction monitoring to continue to check back on the site, make sure that it's not experiencing any issues with erosion or different things that might need to be rectified. So overall timeline, I would say that the shortest a project could be done is about 3 years, but depending on the grant funding cycles, a lot of grants also require you to have your permits in hand before you can apply for them for construction funds, so sometimes there's a big waiting period between completing your design and permitting and then getting the construction funding. I wanted to mention something when you were talking about, cost to the town. So we have done studies. Studies have been done. We've been involved in one economic analysis for DER that showed that these types of larger structures designed in accordance with the stream crossing standards are actually cheaper over time because of the number of times that these smaller pipe culverts need to be replaced, and especially cheaper to towns because they're eligible for so much grant funding. There's typically little or no cost to the towns, whereas the pipe culvert replacements, the in-kind replacements are all on the town. Plus the cost of the damages and repairing damage to the road and so forth.
But I think the question, clarification though, when we do apply for these grants, to get those grants, we will be restricted in what we can have and not have from an aesthetic engineering design perspective.
Not really aesthetics that I can think of. It's really just that most grants will not support a project unless it's fully meeting the stream crossing standards, which again is required anyway. So there's really no loss in having a grant supported project. You still have plenty of leeway with the aesthetics and look of it. It's really, this constraints of the site and different things like that that would dictate that.
I just need to bring it up, because there's been a 5-year concern about a bridge being placed in the town for the last 5 years that was really designed to look like 495 or Mass Pike. And I and many of the neighbors have been trying to work with the town and Mass DOT to make sure that it is pleasing to the residents in the environment of Drift Road.
Mhm.
So we're just, want to ensure that these two culverts follow, I think, some of the recommendations that the neighbors have laid out to the current engineering firm.
Yeah, sure.
And to Mass DOT.
Yeah, we've been-
Evelyn and I have talked. So
Yep, we've been getting that feedback, and we'd definitely take that into consideration in the next phase.
We're more than happy to meet and consult to give our 2 cents when we can. But a lot of this is about guardrails, and, we know we talk a lot about the fish, but we live there.
Mhm.
So we gotta take care of the residents and the people that come to Westport. that,
Sure, yeah.
Use the roads, vehicle and a bike,
Mhm.
bicycle, and a perspective.
Yeah.
And then the natural side of things.
Mhm. Thank you.
So having some oversight of the project on the town side, we want to take that experience from the Kirby Brook Bridge and apply it to these culvert crossings. And so taking into consideration, like you said, the guardrails, we were just talking this afternoon about when these go through the design phase, that there's adequate room for recreation on the shoulders, so for bikers and walkers. There are a lot of folks that use those roads for, outdoor recreation, and to take those other design considerations, and see what we can do to make it just, like you said, not just like a concrete box culvert that might, and as opposed to that, have something that is a little bit more aesthetically pleasing as opposed to just like a concrete kind of industrial looking application.
And I know there's talk too about maybe recycling some of the granite that you're going to be removing. And we're talking about that with our bridge too. So.
Yeah.
Who was involved in the Kirby Brook Bridge? Were you involved in that at all?
Nope, I can't, you can't blame me, no.
It's the town.
Initiated thing?
Yeah, it was the town initiated the small bridge grant, and to fix
Right,
the bridge, and
right,
they got involved with Mass DOT, and things kind of got out a little in front of them first, so.
yeah.
But I think it's, I don't know.
Well, I just want to thank.
Yeah, I'm not working on that project, but yeah, the highway department had applied for the small bridge program grant. I'm not sure who the engineering firm is on
It's
that.
par engineering.
Yeah, and obviously it's been, 5 years of a discussion, I'm sure. But I just want to thank you for making this presentation and for being involved, and clearly the ecological concerns and the fish habitat and the water's flow are very, very important things, and you clearly are looking at those. And I think just from, residential, from the residents of the town who use the road, to reiterate, we would like to see something that is usable for not just cars and aesthetically pleasing,
Sure, yeah, definitely.
that fits into the countryside.
Yeah, Thank you.
What's the design GVW standard, what are these bridge, this type of culvert, specifically over Angeline, what size truck is it designed for? What GVW?
oh, I don't know that off the top of my head, I'm not the structural engineer, so I know that they look at that, but I don't know the number, sorry. But, whatever would be required for that roadway classification, these are classified as
Michael?
local roads.
I don't
Yeah.
have an engineering background.
Okay. Well, that's interesting, because a lot of heavy trucks go over Angeline Brook.
Yeah.
Road bridge now.
Yep, it will definitely be overbuilt, I can guarantee you that, based on the standards that we have to design to now, and earthquake, seismic design, and all the different live loads that you could experience from both the traffic and other factors at the same time, so yeah, they're very well.
It will look considerably different than what's now.
Yeah.
Yeah. Yes and no, I mean.
Have you lost some sleep over the design of that culvert?
Me?
Yeah.
Of the design of the Kirby?
Yeah, no, the Lionsbrook one, because
Oh.
of the limitations.
Oh, yeah, that was very challenging.
I had a suggestion that, this may sound facetious, but they include some money for 50 gallons of vinegar to spray all the galvanized guardrails before they're erected,
Mm.
so that they oxidize and they're dull. Because
Mhm.
that seemed to be a lot of people's objection with the Kirby Brook project, was that it was like this gleaming silver thing that took, I don't know, 9 to 12 months to
Fade.
oxidize.
Mhm.
If we could do that right away, I think it would help people with the shock.
Okay, thank you.
Does it have to be galvanized steel?
No, there's definitely,
Can it be wood?
there's other options available. We started looking into that, but again, we still need to figure out what's required and what options are available. We've looked at wood. I don't know if it's,
Yeah.
Has to be galvanized?
Angeline Brook, you could probably do Corten, which is the rusted brown guardrail.
Okay.
This is what I know. You could probably do Corten there with wood blocks and wood posts.
Okay.
That's what we're asking for at Kirby Brook. And we're hopefully able to get that. Or we could paint the guardrail a certain color that would fit in versus the galvan. So yes, you can get something different. Wood, you can't get a wood guardrail. You could get potentially you could get a wood steel backed guardrail. So it's a plate of steel behind it, but that's, Angeline Brook probably won't get that because it's too big of a bridge. I don't think they allow those
yeah,
bridges in.
that one will have stricter
But there are
requirements.
other things we could do, like we're asking for, I don't know if you know this, Rick, you know this, we're asking for an inlay of granite in our wing walls. So that instead of it just being concrete, we want them to be able to cut it out, and so we can put granite there to match the historic bridge in the background. We also asked for a precast concrete culvert that looks like stone.
The stamped.
So it's just not cement.
Mhm.
There's one at Trip Brook, if anyone knows where Trip Brook is on Drift Road, stop your car there, go down, and look at that. The town did that with all their own money, and I think some grant money in 2012. They did a nice job, and they have a stone wall, there's no guardrail, there's nothing there, and it's probably the largest drop-off in the town, it's about 15 feet.
Yeah,
drop
it's a
off.
deep road.
It is.
Mm.
But go look at it, it's a nice culvert, and that's what we're asking for too, something like that. And then the wing wall is something different. The other thing is, with guardrails, approaching the bridge, you will have to have, at the beginning of the guardrail, the wing, well, you'll have that crash pad, you know, that big yellow hit me here. So, there are some options for that where they can temper it down a little bit. So there's one that looks like an L and stuff. So I live right in Kirby,
Mhm.
so this was gonna be in my front yard. And I
Sounds
just-
like you should be having
so-
consults.
Well, I've offered, so and I will.
I mean,
I'm sure.
who's making the decisions, really?
A collaborative team decision of the
Right.
partners with input from all the stakeholders and
So,
the residents.
And, you know, our bridge project is a $3.5 million bridge, and what we're asking for is probably $100,000 of additional add-ons, if even that, so.
I
Anyways,
see.
there's things we can do, and that's why I'm encouraged, because we've looked at a lot of what Buzzards Bay has done. They've done a really nice job in Mattapoisett.
Mm.
The Trip Dam, is it?
There was actually the project manager.
That's, we wanted that to be at Kirby Brook, because you did a really nice job. That is done well, so that's another example. And the one thing that we were looking for, and I expect we'll have it here, is rendering. So we see the nice pictures, which are nice, but it would be nice that the engineers, when they get to that,
Yep, we do that.
what's it gonna look like
Yeah.
to us, the people, and what can we see and how is it gonna look?
Yep. I was gonna ask too, is Kirby Brook a little more open? I wonder, because, just from doing field work at these sites, there's a lot of vegetation on the upstream and downstream
It's not
sides.
open. It's wooded.
It's wooded, okay. I just didn't know of the visibility difference. Yep.
You said it could be up to 5 years before this project completed,
Mm-hmm.
how long is the construction phase?
Typically
From
about
start to-
2 to 3 months, depending on the size. I think the
And
smaller ones could be
will
done
that
in 2.
likely, that means the road is closed.
Yeah, for most of these, there would probably be a closure because there are detour options available. And
And you
that would,
said, how many months?
2 to 3,
Wow, okay.
yeah.
And would you do them consecutively, like right after each one?
It depends. I don't know if they'd all get funded at the same time, so we might prioritize one over the others, or, the team would. And, yeah, I don't think, we wouldn't have all 3 sites opened up at the same time, I don't envision.
So I don't know, Angelina, is there guardrails and stuff there now or anything?
Well, you can see in the
Head-
photo.
there's head
It's kind of
walls.
like a low granite wall.
Okay.
Yeah.
The plows have begun chipping away.
I should have included
So
more
just so you
photos. I
know,
didn't-
there will probably be,
You can see it. That sticks above the road surface about
where-
10 to 12 inches.
The-
just the stones?
The
That's-
granite, it's a little more visible on the
So
upstream
you will
end.
then now, you will have probably, and that's pretty straight there, is that straight, is that really
It's pretty straight right there.
Yeah.
So, but you'll have probably 75 feet of guardrail on both sides. Don't quote me, but you will have guardrail. You
That's
won't
why
be
we
short.
want it to be aesthetically
Yeah.
pleasing.
It won't be, I mean, we had nothing, and we went to 165 feet when the town put the guardrails in 5 years ago. And then when we got the bridge grant, they increased it. They
Yeah,
said-
this is
so it's like
26
200
feet or something,
Mhm.
26
For the
feet?
width of the crossing, yeah.
Right, and now it's only half that.
Yeah, well, it's 10 plus the buffer between, so it's probably 15 at least, yeah.
But you'll have, so then you'll have guardrail 26 feet and probably, again, maybe another 30 feet this way and another 30 feet, so you could be up to 80, 90 feet. So I'm just saying, but that's the Mass DOT standard for
Mhm.
that, so.
Mhm.
I'm, again, not an engineer, I'm just telling you what I've learned and what we've discussed in my conversation.
Yeah, thank you.
Dick,
Other questions, comments?
Thank you very much.
Thank you all. Good questions and feedback, thank you.
Thank you.
Before you all, we can clap, Jill.
I'm sorry for my coughing spell, I'm getting over a cold.
Before you all go, if you have any questions at all, you can email me. It's mortimer@savebuzzardsbay.org. It's also on the sheet up there. I'm writing on a piece of paper for you. But thank you all for coming. When doing these projects, we're looking at infrastructure and flooding and public safety, as well as ecological resources. And that's why we have these public meetings, because guardrails are what, is not in our original proposal, but we want to make sure that the town and the residents who live there are involved. And so thank you for giving me your feedback.
So
Will
you
there
guys,
be another one of these, or how?
During the preliminary design phase, yep,
Okay.
there'll be another public meeting.
And if you'd like an invite to attend the select board meeting, they'll be doing this same exact presentation, so you can give the select board some feedback. Just make sure you sign up on the sign-in sheet, and we'll send you a notice before that.
okay. So I do have to say that we did a lot of research on what Buzzards Bay Coalition has done, and you've done a nice job, and I'm looking forward to working with you guys, because I think we didn't have that. We just didn't have the resources initially when we did our bridge, listen to me. But this is nice to have, you helping shepherd this through, and you as well. So, and I know that your company has done a lot of these.
We do, and
throughout the-
all I work on is restoration projects, so whether it's culvert replacements, dam removals, fish.
Very concerned about that stuff around here.
Yep, so we're not just another municipal crank-out bridge type of firm. And we don't work on DOT bridges or highway bridges, so just these small ones. Although inline is fairly large, but yeah. Well, thank you.
Thank you.
Thank you.